told that a hot piece of metal weighing 350 grams is heated to 100 C, and then it's placed into a calorimeter with 160 grams of water at 22.4 C. So the H2O warms and the metal cools until the final temperature is 35.2 C. And we need to find the specific heat of the metal. There are a few things we need to realize here before we get into any kind of equations. This 35.2 is the final temperature of the entire system, including the copper and the water. So, since this is a calorimetry problem, we're going to be using Q equals specific heat times mass times the change in temperature. And by the law of conservation of energy, which is Q, we know that no energy is going to be lost or gained from the system. We know by putting that piece of copper into the water, the energy from the hot copper is only transferred to the water. So no energy is lost by the system. So we can also write this equation here. The energy of the water is equal to the energy of the metal. And we can calculate Q from each of these. So I'm just going to substitute this into there. So we've got the specific heat of water times the mass of the water times the change in temperature of the water equals the specific heat of the metal times the mass of the metal times the change in temperature of the metal. And this is what we're looking for right here, the specific heat of the metal. Now this is something your professor is probably going to want you to memorize, the specific heat of water. So the specific heat of water is 4.184 joules per grams Celsius. We can find everything else here. We know the mass of the water is 160 grams. We know the change in temperature of the water because the entire system ended at 35.2 and the water started at 22.4. So we can calculate that, and it ends up being 12.8 degrees Celsius. This is what we're looking for here. We know the mass of the metal is 350 grams. Now we need the change in temperature of the metal. Well, it started at 100, and the entire system, including the water and the metal, ended at 35.2 degrees Celsius. Now, change in temperature is usually final minus initial, but you can't have, since we're looking for specific heat, you can't have negative specific heat, because the very definition of specific heat is how much energy it takes to raise 1 gram of that substance to 1 degree Celsius. How much it takes to raise it 1 degree Celsius. So we're not going to worry about, because technically if we did this, we would have to do 35.2 minus 100. But that's going to give us a negative number, which in turn will make this specific heat negative, which you can't have negative specific heat. So we're just going to take the absolute value of this. Basically, we're going to do 100 minus 35.2, and we'll get 64.8 degrees Celsius. So now that we know what everything is, we know the specific heat of water, mass of water, we know everything that we need. And this is what I was telling you the other day, that this is exactly why I like to rearrange my equation before I plug in any numbers. So I'm going to be rearranging this equation right here to be able to solve for the specific heat of the metal. And what we end up with will be the specific heat of the metal equals the specific heat of water times the mass of water times the change in temperature of water. And then we're going to divide that by the mass of the metal times the change in temperature of the metal. So I'm going to go through and plug all these numbers in here. 4.184 times 160 times 12.8, and we're going to divide that by 350 times 64.8. And in the end, we should come out with 0.378 joules per grams degrees Celsius is the specific heat of the metal. And it tells you to identify it, but it tells you in the problem that it's copper. But you can go to a specific heat table and find this number and find out that it's copper. So if you have any more questions on how to do a problem like this, just let me know.